Ricardo. Good afternoon, everyone. Hope everyone's doing well. So I'm Dave McDonnell. I'm visiting from Houston, Texas. I had the chance to come a day early and look around. I want to take some of your art back on the plane with me because I went to the Rijksmuseum and the Van Gogh Museum, and it was just fabulous. So having a nice visit so far, and I hope you are as well. So I'm going to talk briefly about why we're here. We're here to talk about the concepts of AI scalability for a decade. We have a lot of experience in distributed computing, starting in the world of high-performance computing, getting into analytics, now trying to help customers as they chart into data science and their path to AI. So we'll talk briefly about the path to AI. We'll share with you some of the challenges that customers are sharing with us, and we'll share with you the concept of no AI without an IA, an information architecture, to help customers get through these challenges. So we'll spend very little time on this, but there isn't an industry, nor is there a geography where we don't see customers wanting to very quickly develop their models and get on the path of ML. Of course, everyone wants to get to DL eventually, but most of the activity that we see today is in machine learning. So machine learning, of course, starts on the foundation of analytics. And if you're going to pull in sources of data from the cloud, from all your systems internally, you need to have an infrastructure that you can work with to be able to handle that. And if you want to do that over the next decade and project out, you want to be able to do some planning. So in essence, we believe that cognitive applications require a cognitive infrastructure. You need to really have a top to bottom thought process and plan to help get through a decade. And that's what we're going to talk about. So we have the chance to listen to a lot of customers. Conferences like this for us are a lot of fun because where else can you come and listen to 20, 30, 40 customers in a single day? So we've done a fair amount of this. And we have shows of our own, industry conferences. We love coming to the Spark Summit. We've been coming to it for a few years now. But I sometimes ask, is this the experience anyone here? Sometimes people feel like they're put on the spot. They might not want to admit it, but this has been fairly common in our experience based on what we hear. So customers starting down the path, they're usually starting a data scientist somewhere or an analyst somewhere. They've got a sponsor, VP, a director, and the technology building block is usually a laptop as a first starting point. And they're starting programming in an R. If they're moving to unstructured data, they'll be in Python. And they're trying to see, can I get something working? Can I build a model that will work? Can I start taking some of these concepts and putting into practice in a meaningful way for my sponsoring VP, director, whomever? And once they have something that they believe is working, they'll oftentimes want to test it with a GPU, the graphical processing units that are now used to do math, analysis, sorting, whatever. So a lot of times that will start in the cloud. It could expand in the cloud. And now I'm seeing, does it work? Do I have something that works? Is this ability to ingest all this data and to help produce some kind of intelligent insight or answer? Is it feasible? Is it possible? So we'll see those often take place in the cloud or on-premise, but often on the cloud. Why? Because it's fast. It's easy. And then, of course, there's usually progress, right? Because there's lots of tools and there's vendors that can help customers get to a meaningful process. There's training available. There's books available. There are consultants available. So then we see an expansion phase. And in the expansion phase, we could see growth in the cloud usage. We often see infrastructure starting to pop up on site. You could be starting with a GPU workstation, a GPU server. In essence, it's usually something more than the laptop that I started out with when I was doing R programming or Python programming. A lot of times, these are workstations. And a lot of times, that's because if I buy a workstation, I don't have to deal with my IT department. Right? If it's a server, I have to go through IT, right? Yeah, and it's slow, and gosh, those guys are difficult to work with, and they want me to talk about governance and security, and 3-6 months later, so I buy a workstation so I can get something done quickly, and my VP is breathing down my neck every day, asking for an update. Where are you? Are you getting this? Can you tell me something meaningful about my inventory or my marketing customers? There's a lot of pressure on data scientists. This is not easy. So after that, Well, things actually go pretty well. When you have a VP or a director breathing down your neck, that usually gives you a lot of motivation to learn and learn quickly. So you'll see workstation number 2, workstation number 3, workstation number 4. You could start, oftentimes customers start sharing data just simply with a USB drive, then potentially a disk array, a second disk array, and so forth. Now, project that out for 3 years, for 5 years. Not very efficient, right? So a lot of times the data scientist teams, they're sharing with us that their hardest problem, the most difficult challenge they have, is sharing information. And that's data science speak, right? If you were an IT person, the speak you might use is a single domain namespace, right? But that's not what the data scientists say, and it's not how they speak, right? They're not coming from an IT background. So this is difficult. This is difficult for sharing information. It's difficult for growing. It's difficult for performance. It's you have a lot of inefficiency. We see replicated data. We see multiple versions of the truth. So it's difficult. It's a challenge. And in the world of Spark analytics, we've now seen cluster sprawl. Now, for those of you who are not from IT backgrounds, server sprawl was a pretty big challenge. Right? Server sprawl, managing all those different servers out there. There's all kinds of different management vendors out there to help manage that. Well, guess what? We also had storage sprawl. Now we're actually seeing cluster sprawl. So the last show that I went to that was purely focused on analytics was a Cloudera show. And as I'm listening to customers all day and interacting with them, I would say the average customer from a large organization had about 10 different clusters. I spoke with one that had 50 different clusters. So here you are. You have building blocks that are hardware-based. So a lot of times you're buying CPUs when all you really need is additional storage and data capacity. You have replicated data, difficult to manage, difficult to get good performance out of. In essence, a mess, right? A difficult infrastructure. Interestingly enough, for those that follow or even don't follow, Cloudera used to promote that building block model of a hardware-based scalability strategy. They're now pushing, appropriately so, the separation of compute and storage for better efficiency, lower cost, and easier management. So we see this with Spark, customers that are advancing in Spark. Oftentimes they started with Hadoop, but they're running into the same problems with Spark. So managing data is difficult. Okay? This is an IDC study. This is a survey that was done looking at customers that were 1,000 employees or less in the United States or 500 or less in Canada. And basically, the results of the survey showed that customers dealing with data is the hardest part of the infrastructure. Right? So advanced data management, the volume, the quality, the skills gap. This was the IDC way of capturing the data. The way I hear it, when I hear it with customers, it's usually two things, right? I'm dying from the growth of the data, and I'm dying from the operational cost of managing that data. That's the way I hear it. And I hear that from every vertical, every geography. That's a consistent problem. And so I won't spend a lot of time on this, but labeling the data, prepping the data, too much time spent here. 80% of data scientists' time spent not doing data science, in summary. So we're espousing a vision that there's no AI without an IA, an information architecture. So too much of the data is inaccessible, untrusted, unanalyzed. 81% of users aren't able to understand and grasp what's actually needed to get their AI applications. So this is okay. There's a lot of progress that's being made in this. I think we're coming to the end of the big data era where we have to keep everything and throw it into one massive data lake, and now having more confidence so that we can keep the things that we really need and understand what it is we're going to need and want to work with 5 years from now as reference points in model development. So we, in building an information architecture, a lot of our IP is based in software to help make the infrastructure layers more easier to deal with, to make them easier to deal with and faster to perform and to grow with over time. So here's a workflow level view of what we're talking about. We have object technology to help ingest data. We have technologies to help deal with the data preparation process. So this deals with tagging of data. This deals with curation of data. We have in our Discover is what we use to curate the data, be able to help find data 3 years later. We have in our booth a Power Vision AI tool, which is not for use for a data scientist. It's for a business user, like a doctor looking at a medical image or a sports analyst looking at video footage of some sporting activity and being able to tag it manually with a mouse or with a finger, and then actually using that as a means to be able to tag the rest of the data. A lot of the customers we're speaking with today, that's usually done manually by humans that they pay X dollars per hour to tag the video. So it could be the video of this, the popular basketball player, so you can look at that basketball player, the racing car driver, et cetera. And then after we help with the process of tagging and curating the data, we pass it into a high-speed engine, something we call Spectrum Scale. That allows us to give a lot of power and performance to the training process and then subsequently the inference process. So these are technologies, like a technology like Spectrum Scale, for example. It's been in development for 25 years. It's been used for 25 years for the messiest, hairiest, most challenging data problems. It has built-in policies in it to allow you to move things from one higher cost media down to lower cost media. So let me give you an example. High-speed flash is what you'd want for very fast analytics, but you can't afford that much of it, right? So when you're not using data, we move it down to a disk tier, or for something longer term, down to a tape layer. And anyone know the cost of a gigabyte of tape media? 0.01 cents per gigabyte. Right, a 1/100th of a penny, right? So, but I need 2 copies of the data. Well, okay, let's go to 2 1/100ths of a penny per gigabyte, right? So it's very low cost. It's got a long shelf life. It consumes less power, right? So we're not going to not only we talk about AI scalability for a decade. We also talk about saving you an order of magnitude of cost on data, because if you're like most customers, you're at petabytes today, or you're moving to, and you're going to move to exabytes at some point in the next decade, right? So we try to help customers map this out and map out a plan for being able to use the right media at the right time. You don't want to lose some of this data, but you also don't want to keep it on expensive flash technology either. So these are some of the concepts that we work with and we're prepared to talk about. Without having a workflow level view of this, you have replicated data, you have difficulty managing and governing this, you have high labor costs. I think one of the biggest challenges and problems is your human cost is usually your highest cost, right? Data scientists are specialists, they're expensive, and if they're spending too much time not doing data science, you lose a lot of efficiency. It's a large economic opportunity cost. So we have the ability to help customers work with their existing infrastructure, of course. So we can pull information out of existing systems on the left here, existing data warehouse environments from the cloud. We push these into an infrastructure that we can go full stack. All of our tools can work as standalone, but we can also do full stack, power servers with workload management technology that we have that gives better scale, better efficiency than a Yarn or a Mesos. And as I've talked about, some of this data management pieces to help you lower cost and get better performance. So we put these things into building blocks that are easy to consume at a small starting point, right? Because no one's going to start big. It usually starts small. That's why I spent time talking about that adoption path and what we're seeing. So we package these things into small, easy to consume things that you can start with building block of 1 and go up to your heart's desire. If you haven't looked for a while, we have power servers which are specifically designed for AI and data science. Great backplanes designed for these workloads. And we have scheduling and workload management technology that's a lot more efficient and higher in performance than what you can get with Yarn and Mesos. So I won't read all the details, but in essence, we're faster and we're more efficient. The fast part is easy to understand. The part that takes a little more thought to grasp and a little mathematics is the efficiency gain, right? So we have customers that tell us, they see themselves needing 40,000 servers instead of 60,000 servers because of the efficiency they gain. They can get more work done per server with more efficient workload management. So one of the most fun things in our booth, it's always the most eye-catching, is this vision tool that we have. This is where you have the business user, clicking to help tag something that helps with tagging of rest of information. You tag a few different segments of video, and then we can do the rest for you, right? Big time saver. So these are some of the concepts that we're going to talk about, and I'm going to pause shortly for some questions. But I'll summarize by saying, if you want to get through the next decade, right, you probably can't do what you did in the first, 1 quarter, 2 quarter, as you had that VP breathing down your neck every morning, right? That at some point you have to take some longer term view and plan for the infrastructure. So you have this natural challenge right now where the line of business says the IT doesn't understand the business. Well, you know what? They're correct. The IT people will say, well, you know what? If you want to drop things on the network, you don't understand security and the need for governance and so forth. And they're also correct, right? So figuring out how to bridge that gap and get a longer term view will definitely save you time, money, and help you do better data science. Software is your friend to help you have an efficient IA, as we refer to it. And I think by now everyone understands it's a hybrid multi-cloud world, right? So we're doing a lot to try to help make this simpler for customers. Anyone hear of a small acquisition of a company called Red Hat? Right, so we've acquired Red Hat. We're going to use OpenShift to containerize. We're going to containerize our applications, try to make them easier to give customers the flexibility to go to different clouds, to go to different data centers on their own site, and to make things more efficient. So this is the concept. I invite you to come visit us at our booth. We have domain experts in each of these areas that we've spoken with. And I hope to listen to you and learn about your problems. Maybe there's an intersection between these two, but we will pause here and leave some time for some Q&A. Thank you very much.